Hello, ladies and gentlemen. Today we're going to take a look at graphing sine and cosine functions. So we're going to make sense of that spaghetti graph that you were working on and see how that relates to this new type of function that we're going to graph. So let's first take a look at those sine and cosine graphs that you worked on with your spaghetti. Here are a couple samples ones. Remember that we did this throughout the whole 360 degrees and we ended up with this sine wave you see here. Now the sine wave, notice, starts small like this, goes up, comes back down, goes down, back around like so. Notice that there are really 5 key points here. There's where it starts, there's an up, there's back at the x-axis, then it goes down, then back to that x-axis, okay? So that idea of those 5 critical points become important. The cosine is also a wave, if you can see this here, wave. But instead of starting the same way the sine does, the cosine starts up high, hits the x-axis, back down, hits the x-axis, then back up. Now with both of these graphs, those 5 key points play a big role, okay? And notice the subtle differences, but that they are both waves. That's a big idea, okay? So you need to get these things into your notes. We need to think about this idea of a cycle or a repeating periodic function. So a cycle of a periodic repeating function is a portion of the graph of the function from one point on the graph to the point at which the graph starts repeating itself. So these waves go up and down, up and down, up and down, up and down, over and over, right? But at some point they start repeating themselves. The period of the trigonometric function is the number of degrees or radians it takes to complete one cycle. So to get back to that repeating idea, it goes down, then back up to where it starts, and then it starts a new cycle. So the distance to which a sine or cosine graph rises and falls above and below its axes is called amplitude. So to illustrate these ideas, I have sort of a picture here that kind of illustrate those words. So amplitude, notice, is basically the height of the wave. How high up does the wave go? How high or how low does the wave go? So the idea that this wave is going up and then down, that amplitude is how high up it goes. The period, or this idea of cycling in essence, notice that my wave started right here at the x-axis. It goes up, then back down, then back up to a starting spot in the same location as where it began, on the x-axis. That is one period of the wave. Okay, one period is that number of degrees or radians it takes to complete that cycle. That's one cycle there, and it takes, according to this graph, 360 degrees to get back to where I started. So that's what we're looking at when we look at this idea of period and a cycle and this idea of amplitude. So remember those characteristics we looked at when we compared the spaghetti graph to each other here. Sine, starting at 0, up, down, then stopping again when it gets back to 0. Notice the amplitude is 1 because that is a height of 1. Notice the period to get back to where it started is a distance of 2 pi according to this graph. Those are the things we're looking at, but it continues to repeat itself. Up, down, then back. The next one will go up, down, then back. It continues to repeat itself over and over. Cosine is subtly different. Cosine starts at the top on the x-axis at 0. If you go up like this, that's its starting spot, okay? So it starts high, and then it goes down, hits the x-axis, bottoms out, comes back up, and again, that idea that your spaghetti graph showed one period of 2 pi here, we watched it for one period, that was one period's worth of that wave, okay? So we're going to be looking at those 5 critical points as we graph a few of these. Before we can make our graph, though, we need to understand what the equation is telling us. So please, 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 please write this part in your notes. This is the key to it all, okay? So y equals a sine of x, or y equals a cosine of x. Depending on if you're graphing a sine or a cosine, that is the way the equation might look. Now there's an a in front. This number in front of the sine or the cosine is the thing that's going to tell me the amplitude. Remember, that's how high up the wave goes. So if we want to figure out the amplitude, we take the absolute value of that a. So basically we make sure it's a positive value because we're finding a height of that wave. Now to figure out the period, or how long it takes to cycle back or to get back to where it starts, we're going to take a look at a different part of this equation. Sometimes there will be or actually all the time, but sometimes there will be a different number other than 1. There's that number in front of x, okay? That number in front of x, that b, is going to be there, and that thing is going to tell me some information about the period and the increment that I'm going to use to graph. So this might not make complete sense now, but it will when we do a few examples. So the period is found by taking 2 pi divided by that b value. And then the increment that we use to graph, we'll use the period, basically what we got on the blank before, and divide it by 4 into 4 equal spaces. And you can also think about this as 1/4 times the period, whichever one you want to do, the period divided by 4 or 1/4 times the period. So let's graph a few. I have 3 here ready for us. We'll graph these. You're going to need to sketch this in your notes. I need all 3 examples because they're all a little different into your notes, okay? And when we sketch these, we're going to have to sketch them from scratch, x and y axes. I would suggest you use a different color. So you might want a few colors. You're going to see me switching colors here. I would suggest you get a pen, pencil, maybe a highlighter, whatever, and you can incorporate those colors into your graph, because color really is going to be a key thing for us as we get into more complicated graphs as we go along, okay? So let's first take a look at this equation just with a regular pencil here. Let's figure out what we can know based on this equation here. So the amplitude, if you remember where our setup was, the amplitude is determined by the a, and the a is what's in front of the sine or the cosine. So I see an a value of 2, that means my amplitude is 2. That means my wave's going to go all the way up to a height of 2. Then we can go ahead and figure out the period. The period is 2 pi divided by the b. The b is the number that's in front of the x. What number's in front of that x? Just a 1. So I take 2 pi divided by 1. That's just 2 pi. So that means we're going to watch this wave cycle out for the period of 2 pi. When we graph these, we're going to graph at least 2 periods worth. So we're going to count out 2 pi on either side. You'll see that in a moment. The increment is what we're going to use to number my graph. So the increment is found by taking the period and dividing it by 4, or taking 1/4 of the period. So what I'm going to do then is I'm going to take this 2 pi and divide it by 4. So I'm going to have 2 pi divided by 4. Now if I simplify that, I end up with 1/2 pi. So 1/2 pi, or pi divided by 2. So that's the increment. Now domain and range, I'm going to come back in just a minute. You need to make sure that you have all of those blanks into your notes, okay? Now when you sketch these, you're going to need to sketch your own y-axes, and then an x-axis somewhere on your graph paper in your notebook, okay? So a straight horizontal line. And then we're going to actually start basically by drawing in the amplitude and numbering my increments. So we're not actually going to start graphing anything per se before we get our graph sort of set up. So if you want to start at the beginning there, the amplitude says 2. So what we're going to do is basically have a wave with a height of 2. So if you want to start pre-planning this, that means we're going to go up to 2 like this, 1, 2, and we're going to go down to -2 like this, because the height has to go above and below those x-axes, that x-axis there, okay? So -1, -2. We're going to basically have a wave that goes back and forth between 2 and -2 with its maximum height, okay? Then we're going to have to number our x-axes. We number our x-axes in a weird numbering system. We don't number 1, 2, 3, 4, 5, 6, 7 and like we normally would do. The increment tells me how I have to number. The increment says I have to number by 1/2 pi. So that means when I go number my x-axes, I'm going to put a slash, but I'm not going to call it 1. I'm going to call it 1/2 pi, or pi over 2 if you want to shorten it up a little bit. And then if you add another 1/2 pi to that, 1/2 of a pi plus another 1/2 of a pi makes a full pi, right? So pi. So this is 1 pi over 2. This would be the same thing as 2 pi over 2. The next one will be 3 pi over 2, which is the same thing as 1/2 pi. And the last one will be 2 pi. So we're numbering, increasing by basically pi's over 2 each time. 1 pi over 2, 2 pi over 2, 3 pi over 2. This is the same thing as 4 pi over 2, just simplified. The increment tells me how we number our graph. And we're going to do the same thing on the negative side as well. So this would be -1 pi over 2, -2 pi over 2, negative 3 pi over 2, negative 4 pi over 2. So make sure that you're numbering those as you go across your x and y axes there, both positive and negatives. All right, now it's time to actually start thinking about sketching this thing. Here's where another color comes in. That amplitude mark, that is the maximum height I can have. So I always switch colors right here, and this is the maximum height of the wave. And then on the bottom, I'm also going to put one at negative 2. The axis in the middle is called the midline. So this is basically 2 and negative 2. And my midline here is the middle of the graph. Now we actually get to put in some dots now that my graph is all set up. So I'm going to use a different color now, and I'm going to draw in the actual graph. Now remember with sine, sine is the one that starts at 0, so in the middle. Sine starts at the midline. So sine, I'm going to put my first dot right here at 0, 0. Then above the next value that I have on my increment, so pi over 2, sine starts low and goes high. So my next point is going to go up there. And then it comes back down. So on the next increment value, I'm going to place a spot or a point. And then it goes underneath. So underneath my next increment value, I'm going to place a dot. And then it swings back up. So my sine curve is basically generated by placing those 5 values. And it comes back up, and it will again curve around up and down through between my 2 and my negative 2. Now we have to do the same thing on the negative side as well, but let's keep following the trend. So underneath my negative pi over 2, it's actually going to be down here. And then it shoots back up through here. And then it will top out up here. Make sure you're lining them up over your increments. And then it comes back down through there. So here is my sine wave being generated. Now notice I only plotted 5 points basically, right? Just on those major dots, and the rest we can just kind of sketch in. So that is basically the graph of 2 sine of x. Now let's fill in the domain and range. Domain and range we haven't talked about for a while, but the domain is what are the x values doing? Well, the x's on my x-axis basically go on and on forever here. So the domain is all real numbers. However, the range is my y values. Remember that idea that this is going in between 2 and negative 2. So my y values are staying less than and equal to 2, but greater than or equal to negative 2. So my y is between 2 and negative 2. That's where the y values are. That's where the function is occurring. Okay, let's take a look at another example. Here's another one. We have sine 1/2 of x. We have an amplitude. We need to figure out a period and an increment. I'm going to go a little bit faster here. You can pause if you need time to write. So the amplitude is always found in front of the sine. That is going to be a 1 because there's a 1 sine of 1/2 x. The period you find by taking 2 pi divided by the b. The b is the number in front of the x, so 2 pi divided by 1/2. Now, 2 divided by 1/2 is actually 4, so the period is 4 pi. The increment is what we get when we take this period and divide it by 4. So 4 pi divided by 4 is really pi. So I'm going to number my graph by pi's. So now it's time to actually sketch the graph. X and y axes need to go on your graph. The amplitude tells me I just need to go up to 1 and down to negative 1. And now I'm going to number my x-axes according to this increment. We need to count or number by pi. So we're going to count in increasing by pi each time. So my first value is going to be pi. Then I'm going to increase by a pi every time. So that's 1 pi. Then it would be 2 pi. Then it would be 3 pi. Then it would be 4 pi. Notice that I end on that value that is the period. I'm watching it for 1 period out on the positive side. And then I'll do the same thing on the negative side. Negative 3 pi. Oops, and negative 4 pi. There we go. And now it's time to actually sketch the graph. Again, this is a sine graph. So I think I will actually draw in my amplitude here with first another line here. I'm just going to make him dashed. This is the amplitude. This is the amplitude. This is setting the stage for This graph cannot cross those lines, okay? They got to hit that amplitude and then come back down. So you can use your horizontal lines in your notebook for that. So again, this is a sine, so we're going to start at 0. And above my pi value, I'm going to hit that amplitude mark. And then I'm going to come back down and hit the x-axis. Then I'm going to go underneath and hit the amplitude mark. Then I'm going to come back up and hit the x-axis. So these 5 critical points right there, put arrows on the end, okay? Then we're going to continue the same sort of trend, but we're going to have to go under here to continue the wave. Go under. Then we come back up through here. Then we hit the amplitude on the top, and then we come back down to hit the x-axis, and my arrow would be on this end. So here's a picture of my wave. Domain and range. Domain would be all real numbers. However, range would be what are the y's doing? The y's are staying in between 1, so less than or equal to 1, but greater than or equal to -1. So that range is going to be, tied to that amplitude very closely. Okay, there's another picture of a sine graph. Just in basically the numbering system's changed a little bit, right? So here's the third one we need to do, third and last, cosine. So the amplitude here, the amplitude is what's in front, that would be a 1. The period is 2 pi divided by the b value. The b value is right here in front of that x. So 2 pi divided by pi. Well, the pi's would simplify, right? And you'd end up with 2. So that means when I go to get this increment, I divide that by 4. So 2 divided by 4 is 1/2. 2 over 4 is 1/2. So that means I'm going to number my scale by 1/2 when I number out that x-axis. So now we're ready to sketch. We've pulled all the big pieces of information out. Y, X. Now let's get our amplitude drawn in there. Amplitude of 1, so we're going to go up to 1, down to -1. And now let's number our x-axes. Remember, we're going to number by halves, so that we're going to increase by 1/2 every time we go over. So this will be 1/2. The next one will be 2/2, which is the same thing as 1, right? And then the next thing is 3/2. And then the next one is 4/2, which is the same thing as 2. Okay, so these are all simplified versions. If you want to just leave your fractions as they are, or you want to simplify them, that's fine. Just make sure at the end that your 2 here matches your period. That's what we're looking for, to make sure that you've actually numbered out 4 spaces to get that full period, okay? Then on the other side, same deal. -1/2, -2/2, which is -1, -3/2, and then -4/2, which is -2. So now we're ready to place the dots. Let's go ahead and draw in our amplitude marks. This is the maximum height of the wave. It must get to this height. You must place your dot on that line, otherwise it is not accurate. So I will be looking for that, okay? And then we now think about this cosine. This is a cosine graph. Cosine starts differently. Cosine starts high. So rather than starting at 0 like the sine, on the y-axis, we start at a high point right there at the maximum amplitude. We start at 1. With the sine, we would have started down here at the 0, 0, but not with the cosine. Okay, with cosine, we start high, then it goes down. So my next place I'm going to hit is right here at 1/2. And then underneath the 1, I'm going to bottom out. Then back up, I'm going to hit that x-axis. And then up at the top, I'm going to hit that mark as well. So make sure you're lined up on your increments, and then we're going to swing down, swing back up here, and then you just basically arrow down, because it's going to come back down. Make sure your arrow doesn't point up. It's going to come back down, and it would continue to cycle. Now on the other side, we're going to repeat the same idea. Since I'm way up high, I got to come back down through this point, bottom out underneath this guy, come back up right here, and then top out again, so I end right where I began at the high point. And then we can sketch our wave. Make sure the arrow comes back down on the end. So what's the domain and range? Well, the domain, again, is just basically what are the x's doing? Look at, they're numbering out forever and ever. This wave would continue both left and on the right side forever. So the domain is all reals. And then the range, what are the y values doing? This wave is less than or equal to 1, greater than or equal to -1. So we've just graphed some sine and cosine graphs. They take a while to get used to, and it definitely takes practice. So you're going to be practicing some of these, trying to get the feel for pulling the important information out of the equation. But I want to thank you for taking the time to take good notes, and I'll see you later.